Hello, this is Anushka. I'm a second year computer systems engineering student at Middlesex University, Dubai, and this is the video demonstration as a submission for my coursework for the module Engineering Software Development. So before I begin the demo, let me just give a brief about what the system is about. It's called TraceLink, and its primary goal is to verify product authenticity and let customers have access to detailed history of the product. It incorporates a web interface, QR code functionality, and robotic assistance for meticulous piece-by-piece inspections by authorities. So basically, there's a website where companies go and enter information about their product. Every company involved in the production has to do this, starting from the company whose brand it is. So they give an order to either their own factory or an outsourced one, and then logistics people who bring it from one place to another, and finally ending at the store which is housing it physically at the moment. The homepage of the website lets users enter a product ID and shows all of this information to them. So it's accessible to anyone. And for ease of access, there are also QR codes that are supposed to lead them to this website. On the hardware side is a robotic solution that's supposed to help authorities in inspecting these products in stores, comparing whether what they claim on their packaging is visible in the information that's represented by the QR code. So this is my project directory where you can see app.py, which is the main Flask application, along with many other files that it accesses to make this work. Now before I run this, I need to make sure this other application is open. It's called Ganache and it's a local blockchain simulator. I chose to store product data on Ethereum due to its immutability and security features. So here you can see the network ID, the HTTP provider, the address of the account that I'm using, and the private key. This balance ether that it's showing is not my real money. This application also gives me accounts with fake ether for developers to use and test with. Now that I've updated the account information in this .env environment variables file, let's run the application. So when a product is being created, it takes in company ID, the product name, its description, the quantity, like the number of pieces, from company ID to company ID, it can be the same, the employee ID who's typing in the information, the task details about what that intended company that's receiving it is going to do with it, and location that's automatically taken, along with timestamps. So this is the data that I'm going to demonstrate with, which is entered in the constructor of the main smart contract file. First, a few companies are declared with descriptions. The examples are in industries where this product is intended to be implemented in. The first one being Gucci, which is a luxury brand. Second is a food product which poses health risks if duplicated. And third is a tech product. So I've declared a bag from Gucci, a phone model from a made-up company Xiaoji, and saffron. So this is the website that I've designed. Here's where you can enter the product ID and view information. So we have 3 products in the constructor, and the format in which it has to be entered is product ID X piece number, which is how it's supposed to be printed on the product and the QR code as well. So if I type 1x, let's say 2, 1 is the Gucci bag and 2 is the piece number. Here's all the information that we typed in the constructor. An ID was assigned to it. We had typed the name, brand description, and quantity. Next is a security feature added in. In order to detect replication of a single unique QR code on multiple duplicate products, the number of times a single piece has been checked is recorded. Next is the login page. In a practical implementation, these would lead to a company's own login portals, just like us students log in through the MDX portal into websites like Science Direct. But to replicate this, I've created SQL tables with employee IDs and passwords. keeping the table names as the company IDs. Let's try to log in with these credentials from company 11. Once I log in, I'm given two options. One is to add a product and one is to add a log to an existing product. So let's try to add one first. Our company 11 is from the pharmaceutical industry. So let's add a product that is a sleeping tablet. As you can see, it has been added and the product number that I've been assigned is 4. And here's the download button for the QR codes. When I click it, here is the folder. To verify if it's been added, let's go back to our homepage and check. As you can see, other than the things that we've already entered, you can see the number of times the piece has been checked. We just checked it now, so it's 1. And it's also picked up the location. I'm at university right now, so it's picked up the coordinates, the IP address, and the city and country. It's taken the timestamp. If I run this again, then the number of times the piece has been checked changes to 2. So that companies are aware of their product's whereabouts even after it's been handed over to other companies. This system also sends emails to an ID given at the time of registration. These IDs have been stored in an SQL table called TL companies and not on the blockchain because it would be unethical to publicly share an email ID. And if I go to my Gmail account, then here's the email. Now let's try to register. These details must go to the central authority, and to mimic that, I'm using this email as a center. And here's the new company details. So that was the website. Now let's get to the hardware. As shown earlier, we will test with the 3 products that we had added to the constructor: the Gucci bag, the phone, and a saffron box. This is a basic prototype for the inspection robot. It has an ESP32 camera that is used to read the logo and labels on the packaging and uses the Google Vision API to detect the brand. This ESP32 controls the LEDs. The red LED is supposed to light up if the product is detected as fake, and green if everything is okay. It also controls the motors, which move at regular time intervals. So let's get to the demo. Again, the 3 products in our constructor were a Gucci bag, Xiaoji phone, and saffron. But here, we do have the bag and the saffron, but the phone claims that it is Huawei. Therefore, it should show 2 greens and 1 red for Huawei. And it reacts as expected. An alert has been sent as an email with the suspected product information. So, this was my demonstration. There are many areas of improvements, and I intend to continue to work on this even after this submission. Thank you so much for listening.